All right, Dr. Khan, there's a lot of people that are looking at sort of different ways to achieve optimal body composition. Obviously we talk on this channel all the time about diet, exercise, whatever. But when you're starting to look at building muscle, potentially losing more fat, what are some of the things that we're starting to see in the scientific community and even the medical community that are a little different, maybe looking at genes and whatnot?
Yeah, so really what we're using is a peptide gene therapy. So most of your audience is probably familiar with peptides just because they've become pretty popular. And Ozempic, for example, is the most popular peptide. But insulin is also a peptide that was made 100 years ago. So people kind of have an idea, okay, I get what a peptide is. It's basically a chain of amino acids. Usually, by definition, it's technically by like 54, so it's a short sequence of amino acids. And there's one called Follistatin that's been around for, over 2 decades in terms of being studied, but it's a bioidentical peptide hormone in your body. And what it does is it inhibits myostatin. And people probably have heard of myostatin because of those big Belgian blue cows that have a myostatin knockout gene, and so they can put on as much muscle as possible. So if you think about it at a very fundamental level, if you have higher follistatin, then you're going to have lower myostatin, which potentially could increase your muscle mass. And that's why bodybuilders used to play around with follistatin, probably dating back to the 80s or 90s, because it was around. And they used to just inject themselves like every day, and as bodybuilders do. But it turns out that follistatin has a very short half-life. It only lasts for a couple hours. So it's not practical to inject yourself like 10 times a day. I'm sure there are some bodybuilders who did that, but to do that every day for years doesn't make sense. So we had to figure out a different mechanism to do that, and that's where this plasmid gene therapy comes in.
So what does that look like? Is it just basically it's incorporating it into your body over a longer period of time? Like, how does that work?
So it's getting your cell to express the follistatin gene for 1 to 2 years with one injection. And how does it do that? We're using what's called a plasmid. A plasmid is derived from bacteria. It's a way to exchange information. So think of it like giving your business card to someone. When bacteria need to tell someone else a message, they use this plasmid. And so we're isolating that plasmid. So we're not actually injecting bacteria into your body. We're just injecting this plasmid, which plasmids have been around, again, for 20 years. They're well studied. They're inert, meaning they don't migrate anywhere. They don't cause immunogenicity, meaning they don't stimulate your immune system. They just kind of just sit there and tell your cell, hey, produce more of this gene. So people are probably wondering, okay, if plasmids have been around forever, how come this didn't come out earlier? It's because plasmids get silenced. There's something called transgene silencing, meaning when you put a plasmid into your body, your cell will shut it off. And it can do that relatively quickly, meaning most plasmid will only stay in your body for a couple of days. So it doesn't really solve that problem. So again, if you use a plasmid normally and you inject yourself with this whatever gene you want, it's going to be shut off in a few days. And it's not practical to inject yourself every couple of days with a plasmid. So here comes MiniCircle, which is a company I work with. They figured out how to make these plasmids stay in your body longer. So they won't be shut off within a few days. In fact, they stay on for at least minimum like a year with the right dosing, but can stay up to like 2 years. So it's pretty incredible in terms of just a breakthrough technology of getting these plasmids to express the gene of interest.
After today's video, I put a link down below for 10% off of urolithin A from Timeline Nutrition. Urolithin A is what is called a postbiotic. It's something that is extracted, typically in this case from pomegranates, and it's a compound that induces what is called mitophagy. So it encourages the mitochondria to essentially go through a recycling. Now, MitoPure, which is the patented version of urolithin A, has a lot of clinical studies published on it. Very legit stuff. I've talked about it with Dr. Gabrielle Lyon. If you're looking at trying to get sort of I guess you could call it the autophagy of the mitophagy, and improve mitochondrial health, potentially better aging, all these things, urolithin A is probably on the forefront when it comes down to the emerging promising compounds. Really interesting stuff. Not to mention there's evidence to support that it can help protect against visceral fat accumulation as well, which is hugely important. So that link down below gets you 10% off of Timeline's urolithin A. At the very least, at least check out the link and read a little bit more about it, because it's not just Thomas DeLauer talking. This is very real stuff. So link is below this video in the top line of the description.
So mechanistically, like, why does our body have this thing, this myostatin that prevents us from building muscle? Like, it seems like kind of just like a giant, in a way.
Yeah,
it's like, why is this?
Like, I want to get more jacked. Why is this thing stopping me? It's essentially just a way for your body to have a feedback loop or a regulatory mechanism to prevent too much muscle growth, because if you have uncontrolled muscle growth, it can put too much stress on your tendons, and it can put too much stress potentially on your bones. But the other thing too is, like in those Belgian blue cows, for example, they get so much muscle growth that it may increase your risk of cancer too, because you just have this anabolic signal all the time.
Interesting. Yeah, that makes sense. So, I mean, it's almost like I didn't realize that the Belgian blue cows kind of run that risk. So do they, in essence, by having this knockout, do they ever just like snap tendons, or do they have, since they're such a unique breed, it's not just like a myostatin? I know you're not a cow expert, but like, how are they not snapping tendons left and right? Does myostatin have an impact on that too? So you can actually like maybe tensile strength grows or
yeah, I mean, that's one of the biggest, actually, that's a common concern people ask with our follistatin, because they're like, what if I put on too much muscle and my tendons can't keep up? Am I going to injure my tendons or bones? I mean, because of the way we're doing, it's not like we're knocking out the gene. So it's an antagonistic relationship, right? So the higher your follistatin, the lower your myostatin. So it's not like we're knocking it out like those cows, but because those cows have a complete knockout. But I don't know why they don't break their bones or
because they're not pushing their bodies.
I was going to say exactly. Yeah. It's probably because of that. But it's funny you mentioned that, because I treated there's Devin Larratt, who's a professional arm wrestler. He's actually the #1 arm wrestler in the world, and he was because there's some mechanistic data suggesting that in rats, when you give them follistatin, that it might make their chance of having bone injuries, because again, it's the same principle, right? You're putting too much stress on the bones, but what we did, so he was kind of hesitant to do the procedure or to do the injection, but he did it, and it worked out great. He actually won the championship, and he said the reason he did it was because of the follistatin. He said he felt more energy, more strength. He was stronger than he ever was, and he's pushing 50. And he talked about this publicly, so it's out there.
So do people ever, what about from a fat loss perspective? It doesn't necessarily have to be, follistatin gene therapy, but like what are people doing maybe from, an obesity side of things? Like, I mean, is follistatin have an application there? Or, I mean, indirectly, I suppose it would. Obviously higher RMR if you're putting on more muscle mass. But
yeah, it's not just muscle though. Follistatin significantly reduces systemic inflammation. And that's one of the things that we measured and saw in the clinical trial, and I see consistently with patients with biomarkers. So coming back to reducing inflammation, that can help with cellular metabolism, because you have less of those pro-inflammatory cytokines that can inhibit the mitochondria from doing this job effectively. And then there is some evidence to suggest as well it may help with browning, meaning helping with the white adipose tissue going into the brown adipose tissue as well in animals. That they've shown that as well.
So surrounding the world of inflammation, right? Like, I think that people have a tendency to maybe think that inflammation is something that's only going to happen if you're maybe metabolically deranged or you're older. And, for example, I've had states where I know I am in an inflamed state, but if I measure my C-reactive protein, my cardiac CRP is fine, right? So it's like, for people that are trying to understand, like, okay, am I inflamed? Like, do I need better recovery? Like, what markers do you really look at? Do you recommend people look at? Because like CRP is just such, it's one
it's
that's
so broad,
not,
yeah.
and it doesn't mean everything, right?
No.
Like, you can be young, have it, like I have like almost undetectable CRP, but I know that like there's times when my creatine kinase levels are super high. I know I'm inflamed. I'm beat the crap out of my body, right? So what can people look at maybe more objectively that are a little bit more in tune?
So they actually have these cytokine analysis now. The problem is they're not super accessible, meaning most labs don't offer them, but there are very specialized labs in the US that do offer them, and they can measure like interleukin-6, TNF-alpha, and a bunch of other pro-inflammatory cytokines and give you a much more specific gauge of if these different cytokines are elevated, because that will give you a nuanced picture of if you're in a pro-inflammatory state, or if you're producing more of these inflammatory signals than you should be. And then in terms of CRP, there's actually, they have technology now where some of the aging companies like the Generation Lab, which we talked about on a previous podcast, that basically measuring the biological noise, and they can measure inflammation at a nuclear level. So meaning they're measuring CRP methylation. And essentially that's a way to look at that cell itself to see how inflammation is being expressed.
Interesting. So it's almost like, does it act as more of like a lagging indicator? I mean, like, so in a way, like, it's interesting. Like, it'd be nice if we could have sort of the HbA1c of inflammation, right?
Yeah.
Because that's the issue that I always have with, it's a snapshot in time.
Yeah.
Right. Like, and it's like, I would imagine that inflammatory signaling is rapidly changing at different times. And it's like to be able to have an idea of like, hey, how's this actually affecting you at like at a cellular level.
Yeah, no, exactly. And so this test, the Generation Lab one, you can tell I'm a big fan of it. But the reason I'm a big fan of it, because one of the they have like 19 different age kind of organ systems that they measure, and one of the kind of organ systems that they do is inflammation. And so they can tell you your inflammation over time, again with interventions, and then see how much inflammation there is in your body at a more like a DNA level.
That's really interesting. Yeah, that's something that I think I wish more people would kind of be in tune with at a younger age, because I feel like, I don't want to say once the damage is done, it's done. It's not really the case. But if you can kind of have an idea of where you're at, or where, not necessarily even an intervention, but going the other way, like, okay, this kind of training is detrimental, and being able to connect the dots. Like, I'm always in a world of connecting the dots and trying to like, okay, that were, I felt really good that day, so let me try to reverse engineer how I lived that way. But I have nothing objective other than the fact that, okay, I ate broccoli the night before, I did some BFR training, and my brain was turned on. Okay, I'm going to repeat that cycle. Repeat it, didn't work. Yeah. Okay, so it's like, how do I objectively know like what's impacting me in a positive way, so that I can sort of replicate that and understand my lifestyle?
Yeah, exactly. And I haven't found that there are companies out there, for example, that will say, hey, based off your genetics, you should do this type of exercise. But I haven't found those to be particularly helpful because it doesn't actually measure objectively if that's change. If you don't have an objective way to say it. It's just saying based off, okay, your genetic pool, based off like your ancestry, that this is a type of exercise that's probably best for you. And I personally haven't found those to be super helpful. Whereas I found this like way of objectively saying, hey, this intervention is actually making a difference at a cellular level. That's much more of a way to kind of auto-regulate your training.
Yeah. So would you say like, you obviously have looked at lots of different people, like, what would you say sort of the common denominator is for people that, this is going to sound very broad, but for people that are healthy with good body composition? I mean, after treating lots of different people, you say, okay, like, hey, it's people that live this lifestyle, people that live this lifestyle. Like, what are the kind of the common denominators, if I were to ask you your opinion?
So I think by far the biggest thing I see is their ability. I mean, just the world we live in. I think their ability to deal with stress is one of the biggest things. So being able to have that stress resiliency, and being able to not only have like coping strategies, but realizing that if a lot of people have this unresolved emotional trauma that they deal with, and they think that doesn't affect their nervous system, they think it doesn't affect their ability to train or recover, but it can, and it does. And so working through that, whether that's through EMDR, there's vagus nerve stimulations, there's all these different like things out there now that you can do to deal with it. And I think a lot of people don't put the two and two together, because they realize that obviously the mind-body connection and kind of the mental state of your body and your nervous system readiness, it can be affected by that, in terms of how you train.
I want to double click on the vagus nerve stuff for just a second, because I think that has a very strong, just as you mentioned, correlation between someone's ability to build muscle, burn fat, recover, all this stuff. It matters. It does matter. What do you mean by like what kind of therapies, treatments do you do for the vagus nerve?
Yeah, so we actually inject directly into there. So the vagus nerve is a gateway to your parasympathetic nervous system. It's also the fastest, think of it, of a highway from your brain to your gut. So it's like the fastest way your brain communicates to the gut directly. And then there's also fibers that go to your heart, to all your organs really. And so what can happen is when your vagus nerve or your nervous system becomes dysregulated, it can kind of send the wrong signals, which can lead to cortisol dysregulation. It can lead to this fight or flight kind of response all the time, or easily for a lot of people. And it can lead to sleep issues, and it can lead to issues with recovery. So it can create a lot of different problems in that sense. And so what we're trying to do is we're trying to restore balance in the nervous system. So think about it this way. If your parasympathetic nervous system is not functioning properly, then we want it to upregulate. So we want to increase the function of it. And that's why there's these, people have probably heard of like vagus nerve stimulators. Mm-hmm. They've become more and more popular recently. And the reason is because they're trying to stimulate the vagus nerve, right, externally. Mm-hmm. And they're putting like electrical signals in there to say, hey, start firing better. But we're going in there with a needle directly, and we're not touching the vagus nerve, but we're injecting around it. And we're injecting exosomes and peptides, which are basically signals to upregulate the function of it. And then the sympathetic nervous system, there's something called a stellate ganglion block. This is a well-established kind of procedure that's been around for over 20 years. It's been used for trauma. And basically what it does is it calms down the sympathetic nervous system. And we're not, again, we put a little bit of a twist on it because we're not just putting anesthetic, we put peptides as well, because the peptides, as your audience probably knows, can have a modulatory effect that can reprogram cells as opposed to just blocking them.
So does if the vagus nerve, you're constantly in a state of like fight or flight, right? So is it in effect just like an overstimulation where it's just turned on all the time? Is that kind of what's going on?
So it's actually the sympathetic ganglion is turned on all the time.
Okay.
So the sympathetic is a sympathetic chain, and the vagus nerve is not turned on enough. Because the vagus nerve is the relaxation gateway, and the sympathetic is kind of that fight or flight.
Got it. So is that where kind of the influence of like serotonin in the gut versus the brain? Because I mean, that's where, I don't know if you're familiar with this or if you're savvy in this, but where I've always gotten a little bit confused is that, like, from what I understand, the serotonin in the gut can't cross the blood-brain barrier, but it does still impact that pathway.
It does.
So are you familiar with kind of how that works?
Yeah. Well, also the gut is responsible for 2/3 of the molecules in your blood, either directly or indirectly by affecting their synthesis.
Holy crap.
Yeah. So basically your gut has its own, the microbiome and kind of the way it functions is going to affect everything in your body essentially. So it's not just like gut brain axis or something called the gut pancreas axis or something called the gut disc axis, meaning the gut communicates with even chronic back pain, gut joint axis. So it's not just like, because most people have heard of gut brain axis, but people don't realize the gut communicates with all your different organ systems throughout your body, and it has its own, it's like its own little brain, right? That has its own little nervous system as well, the enteric nervous system.
Dude, that's like, you have no idea all the light bulbs that are going off in my not to digress, and I've talked about this a number of times, but like I got a gnarly parasite last August, and so like things were just dysregulated, things were messed up, right? Like 7 ulcers, and it was just like huge gut permeability issues, like very bad inflammation. That was the only time my CRP's ever been elevated in my life. Like it was like a clear like line of connection there. Also coincided with like the worst back injury I've ever damaged my back in my life. I've always had lower back issues, and it was just like, was not recovering. Once I was able to kind of get the gut healing in check, the back started to heal.
Right.
It was like, it was impossible. It's like, why is this not healing? But it was also coinciding with it. So it's like, no one's ever made that connection before. So just for a second though, so it literally, like there's so you said it's the gut disc
axis, yeah.
How does that work?
So there's something called lipopolysaccharides, which is basically a type of bacteria that can translocate from the gut into the disc. And because you get intestinal permeability, aka leaky gut,
and so right there,
exactly, and then it can actually go directly into the disc. And then what does it do when that bacteria goes into the disc? What does it do? It creates pro-inflammatory signals. It's what's called endotoxemia. This is actually prevalent with many chronic diseases, and it's because where does the problem start though? It starts in the gut, and that's why fixing the gut lining is so important. The intestinal permeability, but also having the right gut microbes. That's why gut dysbiosis is one of the hallmarks of aging. There's like 12 hallmarks of aging, and that's one of them. And the reason is because it's so important. It's an underlying factor in driving so many chronic conditions.
It's because it's like, it's now pretty well established, very well established. I mean, even the most, like I say with quotes, like evidence-based people, the people that like are just, like they're just like, they won't look at anything unless there's an RCT. Like even those people are saying like, okay, the link between emotional stress and back pain is very clear now, right? Okay, well, then you look at the link between the gut and emotional stress, the gut and the back. It's like, okay, well, that's, where do we start then?
Yeah.
Like, is it, yes, the emotional stress, and the emotional stress impacts the gut, and like perhaps that's the actual link versus the fact that, there's a lot of very direct linear ways people look at it. Oh, well, when you're emotionally distressed, you're more tense. Okay, well, I'm more inclined to think when you're emotionally distressed, your gut's out of whack, and thus begins the physiological response.
Yeah, no, that's my conclusion as well. And that's why I'm a huge fan of fecal microbial transplant, FMT, which we're manufacturing and we'll have, but to make it more accessible. But FMT is basically transplanting new microbes into your gut, as the name suggests. And this is a procedure that's been around for a while, but still, if you want to get it, it's not super accessible because you have to do it through colonoscopy. Yeah. And it's also, very expensive. And they won't do it for you in the US unless you're basically failed every other treatment and you have ulcerative colitis or something really overtly gut related. Because they still think everything is just, unless it's a gut problem, won't treat the gut.
Yep.
They're still thinking the old medicine, basically.
I have
right?
a friend that went to Turkey, had to go to Turkey to get it done. And it was like they were dealing with, I mean, it was like serious ulcerative colitis, like really, really bad. And that was like one of the only kind of last ditch efforts, and it worked.
Yeah, but it's kind of sad that he had to go to Turkey.
Yeah, it's, and you see it, obviously we talk about fecal transplants like in rodent model research all the time, right? Where they'll take, a feces from an obese human and put it in like a germ-free mouse, and the mouse becomes obese.
Yeah.
It's like, okay, show me how that is not something that matters.
Well, in humans, they've actually done this. So there was a Taiwanese gold medalist who happens to be a microbiologist. So she did her microbiome sequencing, and they found a bacteria strain in her and many other high-level Olympic gold medalists or Olympic medalists. They have this they named it OLP01. And so they take that bacteria strain and they transplanted it into non-athletes, and those non-athletes actually increased their cardiovascular fitness. They got fitter, and their cardiovascular capacity improved. So how crazy is that?
That's same one with, have you heard of Villanella before? Same, different strain, but same kind of thing, except it was more like ultra runners. It was endurance runners. Right. It was, sub 3 hour marathon runners. So it was basically the same kind of thing. Like, okay. Yeah.
So the plan for us is to create FMT. Our first generation FMT it's lyophilized, so freeze dried capsules. So it bypasses the stomach and it can survive and go into the small intestine. So it's going to make it a lot more scalable and accessible that way. So
people, you're eating poop,
essentially, but it actually does something. The problem with probiotics is they're transitory. They don't actually repopulate the gut, most of them. And so this is actually going to repopulate the gut with new microbes. And the first generation one is just kind of like a general like longevity, let's say FMT, and for health. But then eventually we're going to have like specific ones where we have like, we literally get an Olympic gold medalist.
That's cool.
And then we'll have an FMT for athletes. And I think that'll be a very exciting product.
You know, what's funny is I've always joked on this channel, like for years, people that watch my channel for a long time know that, like I've said, like, if you tell a bodybuilder to eat a dog turd because it'll make them jacked, they'll do it. It's like they'll do anything. But what's funny is, I don't know if there's any veterinarians watching, but I've had, I know in the animal world, I don't know if it's legit science or not, because that's not the world I'm in, but I've heard that dogs that go in their backyard and like eat poop, a lot of times know inherently that they need something different. And that, so it's, because it's obviously a problem.
Sense of smell is so,
it's like where they're in tune with, like, okay, I need, so they'll go eat the other dog's poop to try to actually do something. And so
the next time my dog eats poop, I won't yell at him.
Yeah, I mean, maybe he just knows what's up. Maybe he's like, let him do it and he'll get jacked. Well, Dr. Khan, where can everyone find you, man?
Yeah, so Instagram at dr.akhan, Khan, and then our website is eterna.health, so eterna.health.
Right on, my man.
All right.
Thanks, brother.
Thanks for having me.